Hey guys, this is 11.1 day 2. Um, so today we're going to continue talking about histograms. But today we're going to talk about what happens if if a distribution is bimodal, right? So if you take a look at this graph right here, this is a histogram, and you see how it has two peaks, right? This is called a bimodal distribution, and each of those groups of bars, right? You see how you have two groups of bars. Each of those groups of bars is called a cluster. So a bimodal distribution then, when you draw the histogram, it will have two clusters, right? Now, so here is one cluster, and here is a separate cluster. What happens in this case, when you talk about mean, median, and mode, is each one of the clusters will have its own mean and its own median, right? So you will say the mean of the left cluster equals so-and-so, and then the mean of the right cluster equals so-and-so. And this happens quite a bit during quizzes and tests, for example, and often if you hang out in the math corner of the faculty room often enough, you'll hear one of us say, oh, that's interesting, the scores for this test are bimodal, right? So you'll have like a whole bunch of people scoring around, let's say, I don't know, 75, and then a whole bunch of people scoring around like 85, right? So they're clustered that way. Okay, so here I have a data set. These are the numbers of minutes that 30 members of a high school cross-country team ran during a practice session. We're going to construct a histogram and use it to describe the shape of the distribution. And let's go ahead and do that. I'm actually going to make a shape here of my histogram. So I'm going to do the borders, and you can do the same. I just discovered that I can do this. Isn't it neat? Okay. Let's go here. All right. So these are going to be the times. Okay, and of course we want the arrows there. All right, so I actually just put this data into my calculator, and you can do the same right here. We're going to go up here and we're going to label that time. Okay, enter. So I'm going to do on. Sorry, not on. Let's go to current. We're going to go to, I'm sorry, I keep pressing all sorts of buttons here. All right. We're going to add a page of data and statistics. And here I want to make this the time. All right. And in this data, okay, so first of all, I want menu plot type to be a histogram. Right here, but let's clean it up a little bit, right? So in this data here, you see that the minimum is actually 22, and I believe the maximum is 64. So what I want to do is I want to go from 20 to 70, right? And maybe I want to go by fives here. So let's do that. So we go to menu, plot properties, histogram properties, bin settings, equal bin width. I want to make it 5, and I do want to start with 20. Ooh, look at that, right? But I also want to make the y-axis a little bit bigger, so we're going to go to menu, window zoom, window settings, we're gonna go from 20 to 70, and we're gonna make this height, I don't know, let's make it 7. All right, so you see how this is clearly bimodal. And you know by now how you're supposed to transfer it onto your graph. So if this is 20, so this will be 20 to 25. I'm sorry, 20 to 24, and then 25 to 29, 30 to 34, and so on, and you go all the way. And so if you go on, if you hover in the first bar, there are 2 points. If you hover in the second bar, there are 3 points. I don't know. Let's see. Okay, and then if you hover on the next one, there are 4 points, and so on. So you get the idea. I'm not going to waste too much of your time copying this over here. But what you notice is that this is definitely bimodal. All right, and so now let's go to the next question. And this next question says, summarize the center and spread of the data using either the mean and standard deviation or the 5-number summary. Okay, so this is bimodal. That means what we have to do is we have to take it as essentially 2 separate histograms. Now, you see here in the calculator how the histogram sort of gets divided at that 45-second mark. Or these minutes at that 45-minute mark. And then to the left, you have a symmetrical distribution. To the right, you have another symmetrical distribution. So what you're going to do is basically, you're going to re-enter this data, but in 2 halves, right? So you're going to enter the first half and then the second half. All right, so let's go back to our data. What I did for this data is I had done a 1 variable statistic. And you see here that the median is 45.5. That means what you're going to do is you're going to enter the data by halves. Okay, so first up to 45, second 45 to 64. And then you're going to do 1 variable statistic. So you're going to get basically your data, the information for the first cluster and then the information for the second cluster. All right, so if we go back here, basically I want to go ahead and delete these. And what you can do is you can select like this, drag, and delete your data. Okay, I already have the 1 variable statistics there. So now whatever I put in, it'll calculate for me. So now we're going to go back in the table, and whatever number is less than 45, I'm going to put it in. So I have 26. I'm just going to go down. I have 30, I have 41, 36, 37, 31. And you know what? I'm just going to take 45 with this. Just make a decision for that. And I just made an executive decision. Did you see how I did that? And then I have 29, 34. So I'm down to the last 3 columns, 23, 42, and 39. Okay, so what you say is, so now that the 2 clusters were symmetric, remember we have to use mean and median. So you say the mean of cluster 1 equals, what's the mean? 32.8. And then the standard deviation is 7.2. And then I'm going to do the same thing for cluster 2. Mean of cluster 2, and then standard deviation. So the mean for cluster 2, I now have to go and I put in my second cluster. So now it's going to be all the numbers greater than 45. So I start with, the first one is 50, 58, 54, 51, 64, 49, 50, and then 56 and 59, 42 and, no, I'm sorry, 48, 61, 53, 62, 46, and 55. Now, by the way, in an actual, real life situation, you're not doing this, right? So first of all, you have Excel, and then there are lots of like computer programs. So those of you that are going to take statistics next year, you will be given, programs that you can use that calculate all of this stuff for you. Right now, we're getting used to like the fundamental ideas of it, right? So the mean here of cluster 2 is 54.4, and the standard deviation is 5.5. Whew, that was a doozy. Okay, let's move on. We're going to move on to box and whisker plots, because guess what? Those two don't have to be symmetric, right? In fact, the world rarely is symmetric, right? Data is rarely symmetric. All right. So box and whisker plots can also be skewed. And the way it works, again, you have to look at this tail situation. So take a look at the first one that's negatively skewed. Look, there is a larger whisker to the left, right? Larger whisker on left. So we say this is negatively skewed. Symmetrical, you see how both whiskers are equal. Positively skewed, you have a larger whisker on the right. Okay. All right. Now, do you remember what we talked about here? We said when you have a negatively skewed distribution, the mean is closer to the tail and the median is farther. Do you remember that? The median was farther than the tail. And look here, it's the same exact situation. If it's a larger whisker on the left, if it's negatively skewed, look at how the median gets pushed away from that large whisker. And the same thing for the positively skewed. Look at how that median now gets pushed to the opposite side, away from the whisker. All right. Whereas if it's symmetrical, it's right in the middle. Right? So think of, the whisker, the longer whisker pushes away the median. Think of it that way. And then in the case of the symmetrical, if both whiskers are pushing at the median equally, then it's in the middle. Okay? All right. So here we go. What we're going to do is, here we have the cost on a used car website for 12 trucks that are the same make, model, and year. And we want to construct a box plot for the data here and we're going to use it to describe the shape of the distribution. So when I look at this data here, you know what? It's a little bit, this is not sorted, right? So I'm just going to put it in the calculator very, very quickly. And, just so I can get the 5-number summary. And then I can make my box and whisker plot very, very easily. All right, so I have my data in the calculator. This is like one of those cooking shows, right? Where they say, okay, now we're going to put this in the oven for 30 to 45 minutes. And then, they're like, well, okay, so this is what it looks like after you take it out of the oven. Anyhow, so here we, listen, we all have to have a little bit of fun with this. We have the data in the calculator. So let's see here. My median, right? Let's see what the 5-number summary is here. So the minimum is 55, and then the whoa, how could it be 55? Oh my God, I left one out. This was from the last data. Oh my, okay. So the minimum is 6,400, and then the maximum is 9,200, right? So 6,400 to 9,200. That means when I do my box plot, or when I do my number line, I want to go, right, from a number below to a number above. Okay, so, oh wait, I see what the mistake was. This was 5,500. Okay, sorry about that, guys. My cooking show thing failed. Okay, so the minimum is 5,500, and then the maximum is 9,200. So here I'm going to go from 5,500 to 9,500, and I'm going to go by 500s here. So 5,500, 6,000, 6,500, 7,000, 8,000, 9,000, and 9,500. All right, so now the minimum we said was 5,500. My Q1 is 7,000. My median is 7,900. My Q3 is 8,700. Look at how nicely that looks. And then the maximum is 9,200. It's like right there. Boom. Whoa. Boom. Okay, so do you see how this is definitely not symmetrical, right? This one is, so when it says describe the shape of the distribution, this is negatively skewed. And you're probably asking, but wait, the median doesn't seem to be too far to the right. Yeah, okay, so it's not pronounced, right? It's okay. What matters is that larger whisker to the left, right there. So this is negatively skewed. So now, how are we going to describe the center and spread of this data? Are we going to use the mean or the standard deviation? Well, because this is are we going to use the mean and standard deviation or the 5-number summary? Because this is not symmetric and it's negatively skewed, we use the 5-number summary. And so, you just write down minimum is 5,500. Q1 is 7,000. So I kind of knew how this was going to look, and I knew I was going to write it again here. That's why I didn't write these numbers before. Q3, 8,700. And then the maximum is 9,200, right? So if this was symmetric, we would have used mean and standard deviation. But since it's not symmetric, we use the 5-number summary. And with that, I'm going to end right here. And you guys can go ahead and finish up the homework for next time.